Good evening all. Can you please, someone will respond, can you able to hear my voice?
Yeah, we can hear you, sir.
Okay, thank
Yeah,
you.
you're audible.
Yeah, okay, thank you. So today we will see pandas. Okay, we have one more library called pandas. After that I'll give one example on probability. Then there is a concept called imputation. So today we will start with pandas, and then imputation will be there, like some simple imputation. After that I will give some examples, one or two examples on probability and statistics, how this probability density function and cumulative density function you are going to compute by using Python. Okay, so let me start with pandas. Like the last live sessions, we have seen different libraries and different data structures like list, and then numpy, then numerical by. Okay, so we'll start with pandas. Okay, so basically if you want to do any kind of data analysis, okay, you require some kind of data structure and then libraries, right? So you already know a few libraries and few data structures. Okay, so if you want to work on pandas data structure, so you require two data structure. One is series data structure and data frame data structure. I think you already know if you are attending my live sessions. The last session we explained, I have taken one iris CSV file and I showed how to load that iris CSV file into data frame. So after loading into data frame, so we have four different columns in that iris. Okay, iris is flower data type, so there will be petal length, petal width, sepal length and sepal width. These four things we are going to consider it as four different features. So based on that you are going to have three different flowers. I mean the same flower you have three varieties. Okay, three classes will be there. Based on that length and width of the flower, we are going to classify the iris. At that time we have seen data frame and you have seen some visualizations on that iris data sets. Okay, next moving on to next data structure, that is pandas data structure. So if you want to work on pandas structure, there will be two important data structures. One is series data structure and data frame. Data frame you already seen. So the next one is series data structure. Okay, so series data structure, so generally it is one dimensional array like data structure. So it will contain array of data only. I think you already know what is meant by array. Array means a collection of similar kind of elements. Okay, similar means the same kind of data type. Okay, so now moving on to series data type. Okay, let me write here. Okay, series. So this will be introduction to Pandas data structure. So inside this I am going to give few examples on series. Okay, so for example, if you want to create a series data structure, okay, it's like for example, I am going to take it as one label, so that I am going to take it as object. Okay, so the short form of object, this one. Okay, then you can give like this. Okay, series of, you see this one, this is list of elements. Okay, so list of elements, I have 4 different elements. Okay, so this is how to create a simple series data structure. Okay, that this will be the simplest way to form an array of data. Okay, for example, if you run this one, so it's the cell is executed successfully. Then if you want to see what is there inside this object, okay, you just print this one. Okay, so no need of print statement also, you just give object, so you can able to see the elements. Okay, you are going to call, these are the index values, 0 1 2 3 are index values. So and then the type of data that is present inside this series is 4 7 minus 5 and 3. Okay, these are the your customized series data. Okay, so this is index value, and then you are going to have your data value. Okay, so this is how you can able to create series data type, series data structure. For example, you want to know you want to display only okay, I will take new cell. You want to see only values, you don't want index, you just want values. Okay, so you just give object dot values. Okay, you are calling, previously if you call object means it will give the output is in terms of index and then values. Okay, so if you want to see only your values, you just call object dot values, so it will print the list of values that is present in that array. So this is how to create series data structure under Pandas. So next one is you want to print only index. Okay, for example, now I have printed only. So these are, we have different kinds of requirements. Okay, sometimes you want to see only values, sometimes you want to see what is the index values for this data. Okay, so if you want to see that one, then you can call object dot so index. You just try to run this code. Okay, so this is the range of index. So you just see, okay, the range of index, it will start from 0, then it will end with 4. Okay, so 0 1 2, that means top value is 4, always final value will be final value minus 1, that will be 3. Okay, and then each and every time it is going to increment, the index value going to increment by 1. So that is how, if you want to know the index start position and then end position and how much the index value incremented. Okay, it's kind of 1 2 3, or sometimes it may be 1 5 10. Okay, so it depends on how you have created your series data structure. Okay, you can see with the help of object dot index means you can able to know that range. So then you want to create, instead of, for example, here it is started 0 1 2 3. Okay, so I am planning to give my customized index. I don't want to see 0 1 2 3. I want to see this index values as like ABCD or something else. Okay, if you want to do that one, whatever the desirable index values you want, okay, you can able to create that also. So for that, you need to write the code as, okay. So now I am going to take object 2. So my see here, okay. So object 2 series, okay, this is my data. I am giving the index values. If you don't give anything, it will give the default index is, it will start from the 0, then it will increment by one step like this, okay. So if you want to give your own customized or your own desirable index, you need to specify like this D, B, C, A, and whatever the order you are mentioning in this index. So this index values will corresponding this particular values, okay. So you just run this syntax and try to print this value. So just see here, okay. So observe this one, I have created my series data structure with 4 values, okay, and then I have given my customized index D, B, C, A, okay. So whatever the order you are following, it will print the same thing D, B, C, A, okay. So for example, if you don't want E, you just see I'm just customizing, and then I'm see here, okay, instead of D you may have E also, okay. Like this you can able to create your own customized index values, okay. So similarly, if you want to know, okay, index values, okay, if you don't know what is this particular object 2 is containing, like previously you just call object 2 dot the same thing, okay, index value, object 2 dot index value, it will give that index value C, B, C, A, and this D type means data type, the data type is object type, okay. So similarly, if you want to know what are the values, you just call like object dot values, here also you just call the object 2 dot values, okay. So this will be the array. Suppose you want to know C, okay, I want to know the index C value, what kind of value it is, okay. You want to know particularly for this index value. So if you want to print the C index value, you need to call syntax as object 2, you just call mention object 2, let's see. So this is how to print the respective index value. I want to know the index value wherever C is there, I mean in the C index value, what the particular value contains, okay. So you need to call like this object 2, then you just specify that index value in single quotes, okay. Similarly, if you want to know other thing, okay, for example A, object 2, the same thing you call A, so it will print the A value, the respective A value is 3, okay. So like this you can able to print the index values and then the respective output values, okay. So then suppose you want to multiply, for example I have my object values will be 4, -5 and 3, okay. I want to multiply those values, okay. So what you want to do is you just use the multiplication operator, object 2 dot, you just give how much multiplication, 2 or 3. So if you do like this, okay, so the object 2 values will be 4, then I mean the starting value is 4, okay. You just observe here 4, 7, -5 and 3, 4 into 2, 7 into 2, -5 into 2, then 3 into 2, okay. So 8, 14, -10, then 3 into, okay. So you can do like this, you can do any additions, subtractions, multiplications, divisions, okay. You just use the concern operators, you try to manipulate the data, okay. So okay. So the next one is you can manipulate like this. Similarly, if you want to know exponential, okay, so exponential values of the respective values. Someone is trying to. exponential value of this particular thing. Okay, so whenever you are asking exponential value, so in NumPy library you are going to have some function that is exponential function, which is already implemented. I am just calling that function. I am passing my object values to that exponential. Okay, so then you will get the respective exponential values of your values. Okay, so here I have 8 exponential. Okay, so you are going to get the 54. You just use the exponential function. Based on this you can able to get exponential values of the respective. You just want to use exponential function and then you pass this object to that exponential function. Okay, so if you observe each and every time whatever the values it is showing here, so the bottom line it will always say the D type is float type. Okay, previously the D type is integer type. Okay, integer. Now it's changed because exponential will contains float kind of values. So you are going to see the D type data type. Okay, data type of these values. Okay, now what you want to is, for example, you want to check whether index B is present in this object 2. You want to know, okay, whether this particular index is present inside my series data or inside my Pandas data structure. If you want to know, so for that what you want to do is you need to write, you need to check like this. Okay, so my index value is B in object 2. You are checking whether B is present or not. Okay, if it is present it will throw output as true. If it is not present, for example I am giving some R, okay, and then I am checking, so R is not there in my index value. R is not there, right? So that's why it's giving false value. So if the respective index value is present inside your Pandas data structure, okay, so it will throw the output as true. If it is not present, you are going to get it as false. Okay, then similarly you can check other things also like this. You can check. Okay, now what I am doing is I am trying to create one dictionary. I think in initial live session, okay, so I explained dictionary data structure also. Okay, dictionary will contain key value pair. Okay, so I am trying to create a dictionary data type. Okay, so and then I am passing the dictionary data type to my series data. Okay, so let's see. Okay, so you know how to create dictionary data type. Okay, I am creating one dictionary data type, that is state. Okay, these are the standard examples. That's why you can able to see some AI automated content. Okay, so this is dictionary data type. S data, state data. State is Ohio. Okay, this will be the state in United States, America. Okay, then the respective value 35,000, then Texas 71,000. Okay, so this is my dictionary value, this is my key, and then value, this will be key value pair. So what is our intention is, you can create series by passing this dictionary data type to your series data type. Okay, so how we can do means, so now I am creating a new object for this task. Okay, so my new object is object 3. So you are going to pass this dictionary data type, sorry, series. I am creating series. Okay, I am passing this dictionary to this series. Okay, and then you run this cell. Okay, I think there is some error. So what is error? There is some syntax. So if you don't know what is error, you just check the, so that is the, so for example here name error, series is not defined. Okay, so you need to give proper naming. Okay, you need to follow proper naming convention. You just check. If you don't know, see here series is present, you need to use capital S. Okay, then you try to run this one again. S data, you need to run this cell. After that you need to run the second cell. Okay, now I have passed my dictionary data to a series data. Okay, now you try to print this object 3. Now I am trying to print my object 3. See here, you have the state values here texas, and then these are the different index values, and then the respective values you are going to see like this. Okay, so again this is the data type. Okay? So this is how to pass dictionary data to my series. Okay, so and then suppose if you want to pass only index values, so here I have 4 states: Ohio, Texas, and then Oregon and Utah. For example, what I am doing is, okay, I am trying to create see someone message I joined late. Okay, you try to be in on time. Okay, suppose if you missed my class means you check the recorded video. Okay, could you please elaborate where the series come from? Okay, series data structure will be present in inside pandas. Okay, so we have pandas data structure. I am giving introduction to pandas. Okay, so inside pandas series will be there, series and data frame is there. So most of the people they will use data frame to load your data. Similarly you have series also. I am giving introduction to this series data structure. Okay, so now okay, now I am trying to create one more dictionary. Let's see. Okay, states. So without what is this, I am trying to create I got so I am not passing to this dictionary, I am not passing any values. I just have key values. That key values will be state. Okay, California, Ohio, and then Oregon. Okay, you just try to run this one. Okay, so after this, similarly I am creating one more object. See here S data I have sorry, okay, and then index states. You just see this one, this is S data, and then you try to print this object 4. What we are doing is we are trying to print this object 4. Okay, so if you just observe here, so in this object 4, okay, this is my first dictionary S data. My S data will contains key value pairs Ohio and then values. Okay, so what I am doing is I am passing both for this series. I am passing the first dictionary, and then when it comes to index values, okay, so the index values also I am passing. If you don't pass, it will take the S data dictionary values. Suppose I am passing the index value is second dictionary, so then if you see here, so it can able to fetch the 3 states from the, I mean the same states, all 4 states it will fetch it, and the values it will fetch from the here the first dictionary S data. But in California you don't have any values. If you don't have any value, then it will print the NaN. NaN means not a I mean null value. Okay, so it will print NaN value. Okay, so you don't have any values. Okay, so is it clear? Any questions? Okay, I assume that it is clear. Okay, so what we did is we have created
Excuse me, sir.
yeah,
Sir, error is coming that name series is not defined.
You just give S capital.
Okay, sir.
S capital, you and then remaining letters are small letters. And then you try to import the package, respective packages you need to import. So if you want to work
Sir,
on,
main import the
yeah,
pandas.
import
Import
pandas
pandas
as PD. Yeah,
as PD. Okay, sir.
yeah. If you don't import the, I think I already imported. That's why I didn't. See, whenever you are working on these Pythons, you need to import the respective libraries. Okay. So for each and every class, I think I can't able to. You just import this one from pandas. Import pandas. If you want to import only series and data frame, you can import like this. From pandas, import series and data frame thing. Suppose if you want to import everything, you can import. You can use these two statements also. Import pandas as PD. Okay. You can use these statements. Okay. If you want, I can copy and paste these libraries in your chart box. Okay. Any other questions? You try to execute your code with me. Okay. Then only if you have any error, we will discuss. Okay. Huh. Okay, I think you got this point. Okay, we have created we passed two different types of dictionaries to the series, and then we are trying to assign the state values, I mean index values as second dictionary states. Okay, so that's why we got NaN here. Okay, so the next one is, for example, you want to check whether is there any null value is there. Okay, so for that also we can able to check like this. Okay, for example, here one null value is there. California state has null value. So if you want to check, you can call like this, is null and then the respective object. Okay, and then you just execute this one. Okay, here if there is any null value, it will show it as true. If values are present, it will show it as false. Okay, is null. If it is null value, true means you can able to see true here. If there is some value is present, you can able to see the false. Okay, so always this is null function, it will give a boolean type of value, either true or false thing only. Okay, so we have is null. There will be other thing also. For example, the same thing you can do in different way. Okay, this is null. Instead of this, you just call not null. Now tell me what is the output. Not null. What is the difference between is null and not null?
Vice versa of the is null.
Hmm?
Vice versa of the is null.
Yeah, vice versa of the is null. Okay,
Yes,
so
sir.
that means wherever true is there, it will get false. Wherever false is there, it will be true. Though this is two different ways you can check. Okay, if you want to know whether the respective values. So generally what happened is, whenever you are working on your data, okay, so there is a chance that there will be some of the fields, okay, columns, you may have missing values, NA, okay, like this, there will be something null, or sometimes it may be some other thing. Okay, so whenever you can see such kind of fields. Okay, so if you want to know how many, for example, your data set will contains 1 lakh rows and 1000 columns. Okay, so you can't able to see manually, right? You need to use some programming to know. Okay, so which particular field is having null value. Okay, so you can check like this. Okay, So the next one is missing data. Okay, so now as of now you have two different types of objects. One is object 3, another one is, so here I have my object 3. My object 3 will contain 4 states and then respective values. So the next one is object 4. This is my object 4. What I am doing is I am trying to do one thing. Okay, so I want to combine this both the objects. Okay, so for that object 3 you can use object 3 plus and object 4. Okay, sorry, we can use, so what it will do means I am using some arithmetic operations on these objects. Okay, let's see what is the output. Okay, so now you see uh, it will combine both. Okay, for example, you have California and you don't have any value, it will give it as NaN. Okay, similarly, okay, now come to second one. In both the dictionaries you have Ohio and Orion. Okay, so what happened is it will sum up that values. Okay, so here my object 3 Ohio will contain 35,000 here, and then object 4 also you are having 35,000. Okay, if you sum up these two values, so you can get the final value as 70,000. Okay, is it clear? Ohio will contain 70,000. Similarly the other states also. Okay, if you want you can able to combine two objects. Okay, so this is a kind of data alignment. Okay, so then the next one is, so I want to so the next one is we can create index values, and as of now we have used numerical values, and then we used ABCD. Okay, for example, if you want to use names also, you can use it as index. For example, so name also we can create as, so initially I have created object, right? So for that object, so initial, what is my starting object value? Okay, obj. So my obj is this one. Okay, so for this what I am doing is, instead of creating index value 0 1 2, I am trying to give the names. Okay, I am passing names as index values. Okay, I think you have this one. So you can pass, okay, any name. Okay, Bob, Ram, Sam. You can give the names also within single quotes only. Okay, they suggested. Okay, you just give this one, you execute this cell, and then you try to print the initial object, and then you see this is my initial code. Now you see the names as the index values, and the respective values will be 4, 7, minus 5, 3. Okay, so this is, so like this the series data type you can you can use this series data structure like this. Okay, so next what we will do is we will move on to data frame. Okay, so I think you already know data frame. Anyhow, I am trying to give data frame. So data frame generally it will represent like your spreadsheet. Spreadsheet means like Excel sheet. Okay, so what you are going to have, you are going to have some tabular data. So the top row will contains the column values. You are going to call it as features, and then you have rows. Okay, rows will be, you are going to call it as tuples or records. Okay, so now, so up to now we have seen series data structure. Now we will see data frame in pandas, data frame in pandas. So what I will do is I will explain with the help of examples. Okay, so now I am creating data frame. See here it's giving some auto suggestions. Okay, so we have data frame. The short form for data frame is here I have taken as data. We just execute this cell. Okay, there is some mistake. Okay, my data frame is, I have states Ohio like this, and then we need to have year values 2001. It's not. So inside this data frame I have three things. One is state value, another one is year, and then I am trying to create pop. I'm just creating some dummy data frame. Okay, so if you don't understand, let me divide like this. Okay, now you try to run this one. This is creation of data frame. Generally you know how to import a data frame, like you are going to call pd.dataframe something. Okay, but if you want to create your own data type, you can able to create like this. So as of now I have created data frame like this. Then after that I am going to pass this to my frame. Okay, so this is spreadsheet like tabular structure. So this is my frame. So inside my frame now I am creating data frame. The data frame will contain data will be like this. Okay, generated code may submit to license. So now you have created your data from data frame for this data. I have passed this data to here. Okay, data frame of data. So this is my frame. Okay, now what you will do is you try to print this frame. Now you see, okay, whatever data frame you have created, this will be the tabular structure. Okay, you have rows 0, 1, 2, 3, 4. Okay, and then columns, different columns, state, year, pop. Okay, whatever you want, you just give whatever you want. Okay, so as of now I have taken as 3 columns and 5 rows with these values. If you want to create for 50 rows, you can create like this, and then you can do your analysis on this data structure. Okay, so this is how to create data frame, and then how to display or how to print that respective data frame in Python. So this is also one of the data structure present inside the pandas. Now we will see some operations what we can do with this data frame. Okay, so for example, you want to change the order. For example, you want to see the first column as year, and then you can see state. After that you want to see pub. Okay, so for that, if you want to if you are having such kind of requirement, okay, you want to change the columns. Okay, so you need to write the code for your data frame like this. Data frame, see here, data frame. So I want to see the first column as year, and then second column as state, and then third column is pop. Okay, so yeah, Arun, tell me, what is your doubt? Arun, somebody raised their hand. Okay, okay, sir, can we make serial number from? Yeah, we can make. If you want to give separate serial number, you just you can make. Okay, so instead of giving this year, okay, you just give here serial number and then give 1 2 3 4 like this. Okay, then you can take this as first one. Okay, generally it will come with by default it will come with some index values. If you want to give some serial numbers based on your wish, you just give that one. Okay, okay, I think what I am doing is we are trying to print this one. Okay, yeah, see here, now you can able to print the year first, and then state, and then some value, population value. This is population value. Pop means you just assume it is population value, some 1.5 million or billion. Okay, whatever it is. Okay, this is just for our understanding only. Next one, so you have printed like this. Then what to do is, suppose you need to know, okay, you are trying to create one more data frame, but you are not passing any values like series data type. Okay, I am creating data frame with the data means the above data. Okay, we have created one thing, right? So this is my data, I am passing this data to my data frame. This is my new frame 2 I have taken. Okay, so I am passing that data, and then I am giving columns. Okay, so what are the different columns you are having? You have the columns as, year, state, population, and depth. Okay, see here, what I am doing is I am trying to instead of displaying index values 0 1 2 3,
Sir, no data available, sir.
yeah, that's why we need to show if there is nothing is available, then what it will print, you have some data, and then fourth column, previously you have only 3 features or 3 columns. Okay, now additionally I have passed something, another column, that is depth. Okay, now try to run this one and you try to print. Okay, you execute this cell and then print it. You just see what it will print. So if there is no values for this fourth column, it will print as NaN. Okay, it will print as NaN. So what is meant by NaN? NaN in Python is, it's not a number. Actually the full form is NaN means not a number. Generally if you want to represent the missing values, undefined values, and then unrepresentable numerical values, okay, So you need to write NAN, okay. Is it clear? Now you see here, okay. So this is your updated frame, okay, frame 2. I am passing my initial data to my data frame and I have created a new name for this frame 2. I gave the column as fourth column as depth, but I didn't pass any values to the depth, okay. Then it will print as NAN. NAN means not a number. The full form is not a number. That means it may be missing value, okay, or it may be undefined value or unrepresentable numerical values, okay. So if you are having such kind of things, okay, it will print NAN, okay. So how to handle this NAN and all, we will see a little later, okay. For example, okay, I will explain one example how to handle this NAN later. Okay, I will run the basic thing, okay. Suppose if you are having NAN values, okay, let me give one simple example, later we will see. I'm just giving, for example, you just assume that this is my array. I have 1, 2, 3, and then here I have NAN value, my third value, and then fourth value. What I'm doing is I'm trying to NAN to, I'm just trying to give some value, replace that NAN with not a null value with some value, that is 0. I have defined here 0, and then you just try to print this just for your understanding, okay. So if you don't know, okay, I will try to demonstrate this in two ways, okay. So first one is, see, the first initial array is 1, 2, and then not a null value, I mean not a number, and then fourth value. This will print like this. Now we have one function in numpy, okay. This is np means numpy. You just import that numpy package, np dot, we have one function nan to number. Then you give that number whenever you have nan. This is your value, okay. You just pass that x and then give nan value 0 or 5, whatever you want, okay. So this is one way you just okay. See here nan, the 5 is replaced, okay. Sometimes what will happen is you have many number of columns or rows will be there, okay. So there will be some field is missing, okay, inside your data set or entire your data. So what people will follow is, so instead of passing one particular value, they will take the average of that entire column or row. So whatever the average they will get, okay, whenever the missing value or nan is present inside that field, they will try to replace with average value, okay. Is that clear? In your data set, if you want to update your nan or any missing value, they will follow, they are going to use average value like mean value, okay. In statistical terms, okay, they will use mean value. Or if you are having any string type of data, okay, what they will do is they will go for mode. The mode in the sense means the very frequent name they are going to use inside that column, they will take that value as missing value or nan replacement. So this is just for one simple example, okay. So now what we are doing, we are working on these frames, right? Okay. So this is NAN. Okay. Next what we will do is, now you want to know how many columns are there inside your data frame, okay. So now you know, okay, because this is simple, maybe 3 or 4 columns we are creating. In real time you may have n number of columns, okay. If you want to know how many columns are there, you just call like this, okay. You need to view your data frame and then you can frame.columns. These are the syntaxes, okay. You try to remember these things. frame dot columns. You can see all your columns. So and then so if you want to see only specific thing, okay, I think we already discussed this thing in series also. The same thing I can explain here. So if you want to see only state data, you don't want all the columns, you just represent that respective column here, okay. Or if you want to see only year data, so this is one way. Another way is if you want to see the year data, you just call frame2 dot. This is also how to access the respective column, okay. These are two different ways. This is one way with the help of access, I mean dot operator, we can able to access the respective column. This is also another way, okay. You just represent like this, you just represent that column name, you can able to see. So there is some mistake is there. What is that mistake? Here all NaN values are coming. See, actually we have values, but here it is not showing anything. What is the error? No one noticed this thing. Only depth we have NaN, the remaining values we don't have here. What is the issue? So what happened is here, whatever the column names I am passing, here I have created my column names is whatever the naming we followed, right? Here I used capital Y, state S, okay. You need to consider the same thing, but by mistake we have taken the auto suggested values. That's why you are getting NaN here, okay. Generally we have straight value data, right? We need to get those things. Similarly pop also you just check, okay, whether pop, okay, pop you have taken in small letter, that's why you are getting pop values, okay. Now you execute this cell and then this one. Now you check it, okay, the year values and then state values you can see here. So there is some typo. The column names you need to take as it is, okay. If it is small, you just take the small value. If I mean if it is capital, you need to take as it is, okay. So if you miss anything, then you will get the NaN, okay. Now you try to run these things, okay, not this one, here frame2 column, okay. So okay, now here also state is S. Now you can see the state over here. Similarly here also frame2 dot year, you will get all those values. Any questions?
No, sir.
Okay. So this is data frame. Now how to print this, okay. Now what I want to do is, here NAN value is there, right? My depth value. Now I am trying to assign some values for my fourth column. Okay, so let's see. Now I am assigning some common value. Okay, so this is my frame 2, this is my frame 2 depth. So generally depth, you just check the name. Okay, DPT, you don't have any values. Now I am assigning some values to this column. I'm just giving some value. Let's check this one. Okay, so I have assigned some value to my depth column, and then I am trying to print that print that frame 2. Now you check what is there. See here, 16.5 16.5 like this, you have some depth. Okay, so this is one way. For all values you are having same value. Suppose if you want to assign different values, okay, so there are different methodologies will be there to modify the respective value. Now I am showing one thing, the same thing, same depth, I am assigning different values with by using a range value in NumPy. Okay, so I am using np dot so I am calling this range. Okay, now you try to print, you execute this one and you try to print your frame 2. So now see, I am giving some range. Okay, this is my range of values, 0 1 2 3 4. Okay, I have given the range of values up to 5. Okay, so it will take the first value is 0 and then 1 2 3 4. So like this you have different ways you can assign the range values in your data frame. Okay, so then after that what to do? Okay, so now what I will do is, instead of passing range, okay, suppose if you are having any customized requirement. Okay, I don't want 1 2 3, I want some other value here. Okay, you may have different requirements, right? Or I want to see NAN in this first depth, and then I am going to have some value here, after that some NAN value. Okay, so you want to give your customized values. Okay, so for that also you need to give syntax like this. So this is one example. Okay, so this is your customized values. So we have taken the values, okay, in terms of series. Okay, previously we learned series, right? This is my series, so I have 3 values, 1 2 3. Okay, wherever you found index 2, this is my index 2, just try to replace this depth value with this one, with this data. I don't want 0 1 2, I want my customized value. You need to pass like this. Okay, so then what to do, you need to assign this to my data frame. This is frame to depth. You need to pass this to value. Okay, and then you print this, you try to execute this cell, then print your updated frame. Okay, now you check the respective values. Wherever 2 is there, index value 2 is there, you can see the first value minus 1.2. Wherever the index 4 is there, based on this index values only we are trying to update these values. Okay, we are trying to assign some updated values. So these are different strategies. Okay, is it clear? So this is updating the your customized values. Okay, now we have one more thing, that is delete. Okay, so far you have created different columns. Okay, suppose if you want to delete, how to delete? For example, I don't want fourth column. Okay, what to do in such cases? What to do? You want to delete the respective columns. Okay, so for that we have one keyword in data frame, that is delete keyword. With the help of delete keyword you can able to delete anything. Okay, so this is about data frame. Any questions? So like this you can able to do many manipulations in data frame and series data structures. Okay, so with this I am stopping explaining about this pandas series data structure and data frame. Now we will see one more thing. Okay, one more concept called missing value imputation. Okay, I think previously we have seen one thing. Anyhow, I am going to explain again. Okay, live demo. I will show you few more things. So I already have few examples. Okay, let me explain these things. Okay. Okay, what is this imputation means? Imputer. Okay, so if you are having any missing values, you try to replace that missing value with some strategy or some kind of technique. Okay, so if you want to do those things, you need to import numpy package and then this sklearn. Okay, so you need to import this packages sklearn and then numpy. So after importing these packages, okay, so let's see. See, previously I explained on example, right? Okay, so this is some simple imputer, that is mean imputer. Okay, this will be used for ML models or any kind of fitting models. Next one is, okay, see here, uh, here we have some fit function. Okay, 1 2 and then there will be nan, then some value 7 6 is there. Okay, so and then your x value is nan and then 2 is there and then 6 comma nan and 7 comma 6 is there. Okay, so what you are trying to do is, So you are using some kind of simple imputer function. Simple imputer means you want to replace the NaN values or missing values with some simple strategy. The strategy name also you need to pass here, that is mean. Okay, so this is your trained model. So here I am having null value, my x value is having NaN value, and then 2, and then 6 comma NaN, and then 7 comma 6. Okay, suppose you don't have any value here. Okay, so which strategy you want to follow? You need to follow mean strategy. So for that, I don't know, maybe you just go through the recorded lecture videos of NPTEL. There sir is going to explain some what we are going to call is as this fit functions, linear regression. Okay, those things he will explain. Okay, fit means this will be the fit function. Okay, so what it will do is it will take the uh, mean of this thing. Okay, 1, so here we have NaN 1 plus, there is no value, so and then here you are going to have 7, right? So what it will do is here you have NaN value. Okay, it will take 1 plus, here you don't value 1 plus 7 by 2. Okay, you are taking only 2 values, right? So it will replace this NaN with this 1 plus 7 by 2. You are going to get 8 by 2, that will be the 4. Okay, the replacement value. Similarly here also, if you want to replace, okay, 2 plus 3 plus 6, how much? It will be 11, 11 by 3. So 11 by 3 how much? So whenever you have NaN, you are trying to calculate the take the mean value of your fit function, then you replace that with the respective. So like this you just try to execute this one. What is the error? Here np.nan, is it clear? So we have one concept called imputation. Imputation means whenever, okay, let me explain again. Okay, actually this imputation function will come into some kind of model like machine learning models. I think if I will explain machine learning models and then if I discuss this thing, it's good. Okay, anyhow, let me, as of now you just forgot about this statement. So what I am doing is my strategy is, so I have a x values like this. Okay, this is one list. Here I have not a number and then 2, 6 and then not a number and then 7 comma 6. Okay, so there is 2 values are missing. Okay, inside I have 3 different lists. Okay, inside this x I have 3 different missing values, or I have not a number values. What we want to do is we want to replace this not a number with some strategy or some kind of concept that is present in machine learning or Python. Okay, so in Python we have so many libraries. Okay, so one of the library is, okay, so this sklearn, inside this sklearn, okay, so you are going to have simple imputer function. You need to import this package. What this simple imputer means, wherever the missing values is there, based on the strategy here we are specifying the missing values. Wherever the missing value is there, you try to replace, you are defining your simple imputer function, that is imputer short form. Okay, simple imputer. wherever the missing value is there, you try to replace this missing value with min strategy. So now you are replacing with min strategy, but what you required is you required some kind of fit functions. Okay, so if I can't able to explain fit function now. Okay, so for example, y equal to mx plus c, you know this equation, right? If you know the m value and if you know the x value and y value, okay, based on that you can able to from this some kind of straight line. Okay, so if you are keep on changing this x and y values, what will happen? So the line also will vary, right? The slope, the line. Similarly, so there is some fit function is there. So I am trying to give trying to my model. Okay, this is machine learning model. So this is my fit function. Okay, instead of making it to confusion, so this is my fit function. I am giving the values like this. So 1 2 2 3 and then 7 6. Okay, so you have trained your model, this your imputer, whatever the imputer you have defined, you train like this. Okay, this imputer dot fit means you train like this. So then next time what you are doing is you are trying to, okay, as of now you just leave it, you are trying to update. Okay, wherever the missing thing is there, you are trying to update this NAN, wherever not a number values are there, update with some value, that is mean value. Now you just compute, so here I have NAN value. What it will do is, here mean means the average of the three values, 1 plus 2 plus 7. Okay, 1 plus 2 plus 7, how much? These are the three values, right? 1 2 3, 1 plus 2 plus 7, this will be 10 by 3 values. What is the 10 by 3? So you are going to have 10 by 3 is 3.33. You are trying to replace that average value here. Similarly here also 6 comma, now you just try to compute 2 plus 3 plus 6. This is my training model. Okay, fit model. 5 plus 6 11, 11 by 3. So 11 by 3 you are going to get it as 3.66. Okay, so this is how you can able to replace the missing values with the help of simple imputer. The simple imputer is there in sklearn library. You need to import the respective library, you can replace like this. So even in your data set also sometimes, okay, so what will happen is, so there is a chance that you may have NAN or you may have missing values. In such cases you want to replace, you need to follow some kind of strategies. This is some basic thing. Similarly here also, those are the numerical data. Now you just come to, there is a chance, okay, you may have your features or columns with categorical attributes. Categorical means like names. Okay, so if you are having categorical values, instead of going for the strategy mean strategy, so what you will do is you are trying to follow most frequent thing. Okay, so most frequent thing means, for example, here you want to replace this is some other thing. Okay, mode. Okay, categorical means you need to follow mode approach. Most frequent value you are going to upload. For example, this is my data frame. Okay, A, here you don't have any value, here you don't have any value, here A is there, and then B. So there are two times A is there, only one time B is there. Here you don't have any value. The strategy is most frequent. Most frequent is A occurred two times. That's why you replaced this particular NAN value with this strategy. You are trying to print the value as A here. Similarly here also X, Y, so and then Y. You are trying to replace NAN value here. So here X occurred two times, Y is two times. Most frequent one is Y. You are trying to replace that with Y. So this is the advantage of using simple imputer function. Is that clear? Any questions on this simple imputer? Okay. So I hope So okay, I will do one thing. I'll give these examples to you. You try to run this one so that you will get some idea. Okay. sklearn means okay, like scientific kit learn. Okay. So when machine learning came into picture, all these machine learning models they already implemented, and they kept inside this package. Yeah. If you don't know anything, what you will do is you just type that in Google. Okay. Scikit-learn. Okay. The machine learning related things. Someone asked what is sklearn. Okay. The machine learning related things, the implementation functions, models are present in this scikit-learn function. Okay. If you don't know more about these things, okay, let me first, okay, let me copy this code and then I will paste it here in your chat box. Just take 2 minutes time and try to execute this code. So I explained only two strategies. One is min strategy. Whenever you are having numerical data, you try to replace your missing values or NaN values with min data. Another one is mode. Okay, that means for categorical thing. So I send some code, you try to execute that code and you check whether you can able to replace that one. Okay. So if you don't know what is sklearn, if you want to learn more about this thing, I will share this link to you guys. You just go through. Scikit-learn, sklearn means short form is library short form is sklearn. Inside this we have Imputer functions. Okay. So let me explain one more time. I think someone. Okay, let's see. Okay, uh, what will happen is whenever you want to do any kind of data analysis, you need proper data, right? So suppose if you don't have a proper data, what will happen is there is a chance that whatever the plots you are plotting, it may, I mean, it may, it will go in wrong. Okay, based on that wrong plotted data, you can able to uh, take wrong decision also. Okay, so for that, for example, even though if you are getting the missing value data from real time, okay, generally you will get this data from some data sets or any kind of real time data. Okay, so whenever you are having such kind of scenarios, is if there is any missing data is there is a concept called imputation in Python. Okay, so this imputation thing is there in scikit-learn library. uh, Scikit-learn library, what this scikit-learning means, all your machine learning related. Okay, so what is machine learning means? Okay, so if you want to predict something, okay, so what this machine learning is, already you are having some kind of existing data or some model is there. Okay, so with the help of that existing data you need to train your machine in future if you are getting any new values, okay, you want to predict that values, okay. Generally this is basic machine learning thing, right? Similarly here also in scikit-learn library we have simple imputer function is there. With the help of simple imputer function, so we are trying to use the same machine learning thing to fit the values, okay. So for that fit function is there. So these are the respective packages, numpy package and scikit-learn, and then you can import simple imputer, okay. This is as of now we did not use any iterative enable iterative thing. Later examples we are planning to use, that's why I have imported all these respective packages now itself, okay. Now come to here simple imputer. We may have several simple imputers are there. Now I am explaining two things. One is for numerical values. We are trying to replace whenever a missing value is there, we are trying to replace that with some strategy. That strategy is min strategy. So for that we have simple imputer function is there. Whenever the missing values you are telling, okay, if there is any missing value NPNAN, okay. So if you are in your data, if you see this NAN, you just try to replace that with mean approach, okay. So how you are going to replace that mean approach means, so initially you have trained your model or you may have some function, okay. So as of now I am trying to create some manual function. This is my fit function, okay. I am assuming that I have values like this 1 2 2 3 and 7 6, okay. So with the help of this trained function, so here my x value, I have some two missing values. One is the first list itself, the first value is missing, and then second value is missing. What we are doing is we already have some defined function is there, that is fit function. From this trained data I am trying to take the average of, if you want to replace this first value, this one, I am taking the average of 1 value, 2 value, 7 value, 1 plus 2 plus 7, because you are following mean approach. Mean means average only. 1 plus 2 plus 7 divided by total number of lists. The total number of lists is 3. 1 plus 2 plus 7 is by divided by 3, you are going to get the value as 3.3. That will be the, it is going to replace it here, okay. This is my x, this is my x value. Similarly here you have NaN value, this is the second value, okay. 2 plus 3 plus 6, okay. So that means 5 plus 6 is 11, 11 by 3 you are going to get 3.66, okay. So initially so what I will do is, for your understanding, can I print like this? See here, initially I have printed x value like this. So whatever the values are there inside this list, it is going to print the same as it is, NaN, 2, 6, NaN, okay, 7, 6. Then what we did is we are like we used some machine learning models to train that function, this fit function, okay. After that I am trying to print the updated values, okay. See here, whenever you are calling this imputer function, imputer dot the transformation, okay, you need to call this one. So if you don't want to transform also, let me see, okay, I think transform is required. This is my updated one. So the strategy is min strategy they followed. Similarly here also, so we not only having numerical values, we have categorical values also. Categorical means like names. So whenever the names you want to replace with, if there is any missing names or letters, okay. So if you want to do that one, so the mode approach is better one. Mode in the sense means the most frequent values. Here also we have a x and then some missing value, then y is there, a y. Most frequent, the strategy is simple imputer function. What it is following is, so if there is missing here, then you check the remaining, the first values. Here a is there, here a is there, here b is there. So a occurred 2 times, b occurred 1 time. Most frequent one is a. That's why whenever there is missing value is a, this model is considered going, it is going to assume it as this missing value is a, because you have used this strategy. Similarly, the second value also, here nan is there, here x and y is there, and then y is there. X occurred 2 times and then y occurred 2 times. X occurred 1 time and y occurred 2 times. Here y is replaced. So that is mode strategy. And then finally you can see the updated data frame. So here the updated data frame is like this. Okay. So previously you know how to create data frame and all. Okay. So intentionally we have given nan value, and then we are trying to update that nan value with some strategy with the help of simple imputer function that is available in Python scikit-learn library. So that is about simple imputer. We have so many other things also, like we can able to do iterative imputer. Okay. Any questions? So if this is over, so that is about simple imputer. Then I will explain one more thing. So I think you are going through our NPTEL recorded videos, right? I think you have learned probability distributed function, cumulative distributed function. Do you know all those fundamentals, right? How to calculate probability distributed function and cumulative distributed function. Okay. So these statistical things, okay, like probability, static related things, in Python there is a library, okay, that is SciPy library. SciPy means scientific Python. Okay. All these probability, statistical related things in Python will be available in SciPy library. So I'll give one example. Okay. This probability distribution, you just try to import so after imputation, let me explain. Some probability and statistics related examples. Okay. So if you want to work on probability and statistics related things, okay, you need to import this package from SciPy scientific Python. Import stats. Okay, all your stat related things are there in this package, import package, stats package. So after that, what you are going to do is, for example, you want to find out the normal distribution. Okay. What you are going to, you need to call like this. Okay. This is just for normal distribution. Stats dot, this is my package, stats dot normal distribution, the probability distribution of 1, you need to pass this value. What is PDF? See whether you are going through that NPTEL recorded videos or not. You need to go through all those things.
Probability density function.
Yeah, yeah. So what is this norm dot PDF? So maybe theoretically you know how to solve that probability functions, and different distributed functions are there. You know those formulas, but I'm just explaining how to solve these distributed functions through Python. Okay. So what is that norm? Norm means normal distribution, right? Is it clear?
Yes, sir. Yes, sir.
Okay. So you want to find out the okay, let me share my screen. Okay. I will share the I will I will share again, just a minute. Now you can see something. Okay, this is normal distribution, right? So okay, for every distribution, this is normal distribution. You want to know the probability density function of your normal distribution. Okay, so for that you are passing one value. What is that one value? I have called PDF of 1. Okay, probability density function of 1. So what is that one? 1 is your which value? X value. Yes, correct. Okay, so I have passed that one. Okay, now you want to know this normal distribution. Okay, you can able to call this normal distribution also Gaussian distribution. Okay, so this is continuous probability distributed function. Okay, you just go through these basics. What is my intention is I want to explain how to solve this probability density function related things using Python. Okay, so now we have given one x value to my normal distribution. Okay, this is the general form of probability density function. Okay, f of x equal to 1 by this is the value. Now you want to know this value, you just pass that value to this function. Okay, previously you have seen that function. Okay, now you can able to see some value, right? What is the output of that particular code? Now I will stop here. I will stop here. Let me share that. What is that? Yeah. So you see here. Sorry. See, with the help of one statement, okay, stats dot normal distribution, you can able to compute the value. The value for that normal distribution function, if you are passing 1, that will be 0.2419. Okay, so if you want to take it as round off, you can do like round off also. So with the help of one statement, okay, you can able to compute. Okay, for example, let's see if I am giving the PDF as some value. Now see, I am giving 2, that is x value is 2. Now it is changing, the value is changing 0.05. Okay, so this is how to compute probability density function. Similarly, if you want to compute one more function, what is that? Cumulative distributed function. If you are having cumulative distributed function, instead of CDF, what we will do is you just copy this one. If you want to know what is the CDF, you just already function is there in your normal distribution. CDF of, you just give some value, cumulative distributed function, you call some value. Okay, you run this one, let's see. So this is CDF for normal distribution. Whenever the x value is 2, this will be the output. Okay, so this is how you can run, you can execute your distributed functions in Python. to compute PDF values. So if you are changing, for example, there will be several distributed functions are there, not only normal distribution. So you just give proper naming instead of normal. So you want to check any other thing, is there any binomial distribution? What is that? You just check the naming convention. So for binomial, you may have binom, okay. Okay, I am trying to execute one more code, okay, to understand more about these distributed functions. Let me give a clarification whether the probability these things distributed functions are covered in NPTEL recorded videos. Professor Ramesh are discussed these things, right? Okay. Then okay, then it will be easy for you, okay. So yeah, good. You just always try to go through that NPTEL recorded videos week 1, week 2, week 3, then only you can join our sessions, then only you will get few things from us, okay. So if you don't know the basics, then whatever I am giving, okay, maybe you don't understand, okay. So these are the different distributed functions, okay. Now instead of going for direct normal distribution, we have some other thing, binomial distributed function, okay. Now if you want, I will show that binomial distributed distribution in, you just refer this binomial distributions in Wikipedia. Okay. Let me stop here and then. So this is binomial distribution, okay. So okay, this is for binomial distributions, you are going to have probability mass function. Instead of CDF and PDF and all, you have one specific thing, that is probability mass function. So this is the formula or whatever you learn from the recorded videos. So this is the thing, okay. In binomial distribution function, you need to know three values, not only x value. You need to know what is your k value and what is your n value. Anyhow, I am not explaining what is this n, k and all, okay. You need to know these values, okay. So for that, so now I have given one code, right. This is probability mass function for the binomial distribution. Let me show the Python code for this binomial distribution. So Python code for this, just one sample example to understand more about Python code for this distributed functions, okay. So now this is the binomial distributed function, okay. See here, this will be from scipy stats, okay. I already imported this one, okay. You need to import the respective library. Scipy is the library and then the respective packages, okay. You imported binomial. See here, NP values. I think in Wikipedia I have shown that formula. You need to know the n will be the, in this case maybe this will be the number of trials, p value will be 0.5, okay. So then you want to know the probability of exactly 5 successes, okay. For example, you are running on experiment like head and trial, okay, H1 trials. You want to know how many times the head, there is a chance 5 times you will get head, okay. So like that you need to know some value, that is output is some probability value. For that you are using binomial thing. This is your user defined thing, probability of 5 times success. Okay, then you are calling the respective binomial probability mass function, then you need to pass, this will be the success rate 5. Okay, and then you need to pass this values n comma p. Your n will be number of times, the trials will be 10 times, p value will be head and trial. Okay, so the chance of success is only 0.5, 1 by 2, right? So that is probability. If you give this one, you can able to, you just try to run this case. Okay, so there is a chance 0.24%. I mean, there is a probability of chance success. Okay, always you will get the 5 times success will be 0.24. Similarly, the success, okay, cumulative distributed function success will be the same thing. Instead of PMF, you just call the CDF, cumulative distributed function. The concept is same only. I think you know these basic things. Okay, number of times you need to run the experiment. Okay, number of trials, what is the P, all these things you already know. You need to write the code like this, the respective distributed function, and then the respective function whatever you want, probability distributed function or probability, what is that, mass function, or you want to cumulative distributed function. You call the respective function and then you need to pass these values. So that values will be the input for your distributed functions. Okay, then you can able to get your output. Any questions? These are the two simple distributed functions. How to implement these distributed functions in Python? You need to implement like this. For normal distribution, you don't require more values. You just require only x value. For that case, I am just calling. I'm just using the function name like norm.cdf, norm.pdf. But in case of what is this, norm. Okay. So this one line statement is enough for normal distribution or Gaussian distribution. But whenever you want to go for the other distributed functions, okay, so I think you already know when you are going to use non-normal distribution, when you are going to use binomial distribution, when you are going to use exponential distribution. Okay, so those things anyhow I will cover few examples, um, uh, if possible today's session and next live session. So for example, how you are going to decide based on the problem statement which distributed function or which distribution you can select, probability distribution. How you are going to decide? You need to go through the particular problem statement, then you need to select the concerned distributed functions. Okay, so that I will give few more examples.
Sir,
Yes,
give another simple example, sir.
simple example for these two are two simple examples only.
Probability.
Uh-huh. Okay, okay, I will explain with one example. Okay, so far you have
Okay,
learned
sir.
about theoretical things. Okay, now let me explain. I am giving one example. Based on that you try to solve it. Okay, I will give some time to you
Okay.
because you already just a minute, know this probability and all.
Okay, sir.
So I gave one example. I think can you able to see this one, right? So generally the problem statement is like this. The mean response times for a random sample of 30 pizza deliveries is 32 minutes. The population standard deviation is believed to be 10 minutes. The pizza delivery services
Sir,
director wants to
this is
perform.
assignment question.
Yeah, you just try to run the Python code for this example, or else you try to solve it manually. You just try to solve it. Okay, which distribution you want to use for this example. This is the problem statement. Solve using the p-value approach and then the critical value approach. Just go through this problem statement, how to solve this example. Then I will give the Python code for this, how to solve this example. Okay,
Okay, sir.
so all of you go through that particular problem statement, and then so the hypothesis testing concept is completed. Jet test. Okay. So if hypothesis concept and jet test is completed, you can able to solve this problem. Okay. So they have given one theoretical problem statement. What you want to do is you want to frame the hypothesis. Okay. Uh, uh, can you able to solve this one? And then you need to follow two approaches. This jet test you can able to solve in two approaches. One is p-value approach, another one is critical value approach. Okay, so this is the example. So let me explain. Okay, those first I will explain this thing. Okay, I will go through the problem statement. Okay, so they have given, okay, the mean response times for a random sample of 30 pizza deliveries. 30 pizzas are there, they need to deliver it 32 minutes. The time is 32 minutes, that 30 pizzas. Okay, the population standard deviation is believed to be 10 minutes. Okay, so I think standard deviation means you already know what is that, sigma value. Okay, they gave sigma value as directly 10. Okay, and then after that they are going to they are asking the pizza delivery services director. Okay, I mean the company owner wants to perform hypothesis test with alpha level. Okay, so always generally they will take alpha level will be 0.05 only, the level of significance value, to determine the service goal of 30 minutes or less is being achieved. Okay, suppose if they are delivering all these 30 pizzas within 30 minutes or less, okay, then it is good, right? If they are taking more time, okay, what generally will happen, the customers are, for example, instead of taking 32 minutes, they will take some 60 minutes. What is the thing? Okay, the customer will give dissatisfaction. Okay, they will give underrated to your company. Okay, so you need to know these things. You need to solve this by using p-value approach and then critical value approach. So we will see. So here your mu is pizza. Okay, that is mu value is 30. So one is initially you are going to the null hypothesis, you are going to assume it as mu is 30. So that is delivery time. 30 minutes or less than 30 minutes is good. Okay, so this is my mu. Within 30 minutes if you deliver means that will be the good service. I am going to assume it as null hypothesis. The alternate, that is H naught. Okay, the alternate hypothesis I am going to assume it as H1, that is greater than 30 minutes. Okay, so this is these two hypotheses are we have framed. Okay, now you just check the based on the Z score. I think you already know Z test formula. Z equal to x bar minus mu divided by if you don't know, I will show this Z test. Okay, you know this Z test. Okay, so this is the hypothesis framing. You know this Z test formula. Z equal to x bar minus mu by s means standard deviation. Okay, so you know this formula. Okay, based on this we are trying to compute that the required values. Okay, using Python. So for that, okay, now let me solve this one. Let me assign the values, that is Z test. Okay, from the problem statement what we are doing is I am trying to write Python code from the problem statement. Okay, so this is the population parameters. Mu will be the 30 minutes, sigma is 10, they gave directly, and then simple statistics, n value is 30. Okay, x bar is 32. Okay, x bar is 32, that is the minutes, 32 minutes. Within 32 minutes you need to deliver it. Then alpha value is 0.045. Okay, so from the problem statement you are going to have your mu value is 30, sigma is 10, n is 30, x bar is 32, and then level of significance is 0.05. Any question so far? From this problem statement you need to assign the values like this. Whenever you want to solve this one using Python, okay, you need to assign the values like this. The same values whatever they have given, we have considered those things here. Okay, then you need to frame hypothesis. Okay, so for that we are having two hypotheses. One is null hypothesis, another one is alternative hypothesis. This is H naught mu equal to 30 Python. Okay, just a minute. Okay, sorry, now you just check it. Okay, can you able to see my screen, right? Now check it. So what I did is from the problem statement, mu value, sigma value, n value, x bar value, alpha value, we have values like this. Is it clear? From the problem statement we have mu, sigma, they gave everything. Okay, the same thing I have taken in terms of Python code. I have taken some variable names, mu, mu, and then sigma is another variable, n is another variable. Okay, and then alpha is I have given the variable name is alpha itself. Okay, you need to give variable names like this, and then you assign the respective values whatever they have given in the problem statement. So after that you are going to have two hypotheses. These are the my hypotheses. Okay, so one is null hypothesis, another one is alternative hypothesis. One equal to, if it is equal or less than 30 minutes, then it will be the null hypothesis. If it is more than 30 minutes, then it will be the alternative hypothesis. Okay, so after that, so you have framed two different hypotheses. Now you try to compute the Z score value. Okay, so for computing Z score value, you know already formula, Z equal to x bar minus mu. Okay, the same thing I am computing Z score with the help of that formula. So computing Z, okay, I am writing the code here like this, okay, Z equal to x bar minus mu. See here, whatever the variable names you have used, the same names only you need to use here for computing Z value. X bar minus mu by sigma by np dot square root of n. Okay, this is the formula. Then you print this Z value. So you are going to get x bar is not defined. Oh, you need to run this cell. Okay, I forgot to run this cell. Okay, then only you need to go for the next cell. So your Z score is 1.09. Any questions? So is it clear, right? This is how to write Python code for this Z score. Z equal to x bar minus mu divided by the same thing, the variable names, the same names we are converting into formula, then print Z. You are going to have, okay, your Z value. So after that, so what you will do is, after that you just calculate CDF for this. Okay, if you want, you just calculate. Now I am just calculating normal distribution CDF value, cumulative distributed function value, okay, with the help of normal distribution. This is my I am passing that Z value to my, I am using this normal distribution. I got the value as like this 0.86. okay, so then the p value, always p value is, what is the formula for p value? Anybody, what is the formula for p value if you want to compute p value? How to compute p value? How to compute p value? You already know, right? P value equal to 1 minus
alpha.
Okay, what is alpha?
Significance value.
Okay,
0.05.
okay. So if you want to consider alpha, means you can consider directly. Let's see. Okay, I am deriving this p value. You can follow that approach also. I'm just following using this normal distribution. Okay, so instead of taking alpha directly, that is level of significance value, I am just using some normal distribution function. P value equal to 1 minus, I'm just using whatever the values we are getting from this normal distribution. Okay, I am taking this as p value. Okay, so then you subtract it, this value, this particular normal distribution value from the p value, then you have 0.13. okay, so after that, so what to do is just to try to print these two things. One is Z value and then this p value. I am trying to print. If you want, you print it, otherwise you just directly go for I'm just trying to print. So my Z value is 1.09. where is this my Z value? This is my Z value. Again I am just displaying these things, and then my p value is 0.13. okay, so this is, next one is, so the question is, now I am solving, in the question they have given two things. One is p value approach, another one is critical value approach. Okay, so for that, okay, let me take this one. In the question they have given two things. One is p value approach, another one is critical value approach. Okay, so this is p value approach. So since p value is greater than the alpha value, this is my p value, right? What is my p-value? 0.13. This is my z value. So since p-value is 0.13 is greater than alpha, that is 0.05, we don't reject the, because this is true, okay. If it is true, we don't reject the null hypothesis. We have assumed the null hypothesis, okay. You don't reject that null hypothesis. The conclusion is there are, so there are not sufficient statistical evidence to infer that pizza delivery services is not meeting the response goal of 30 minutes, okay. So this is one approach. Is this clear? Another one is, we will see the critical value approach. So for that, instead of computing p value, we are computing z value. So that is z alpha this is critical approach. We are computing the z alpha equal to same thing, okay, 1 minus alpha. We are going to compute, we are using same function. Here you got 1.64. so the conclusion is, in critical approach, since z value is greater than, since critical approach is z alpha is greater than z, we don't reject the null hypothesis, okay. So this will be the two ways. P value approach means you need to take this thing, okay. P value is 1 minus that particular whatever the distribution function you are using. So critical value approach means z alpha, okay. So like this, okay, whatever the distribution is there, you need to write your Python code like this, and then you can solve it, and then you just test your hypothesis. You need to accept it or you need to reject it, okay. So this is one example how to solve like this probability related examples. So with this I'll stop here. Any questions? Maybe in next live session I will give more examples for different distributed functions and how to write Python codes and how to implement different examples, okay. In Python I will demonstrate those things, okay. So before that, if anybody don't have any clarity about this distributed function, probability density function, cumulative density function, what is z score, what is level of significance, okay, you just go through those NPTEL recorded videos or any YouTube or any kind of learning materials. You just go through those basics, then it will be easy for you. Whenever I am just giving this Python code, it will be easy how to implement the mathematical things into Python, or else the problem statements you can able to convert into Python, okay. Any questions? So if you don't have any questions, I will stop here, okay. So what we have discussed is in this live session. So initially we started with Pandas data structure. In Pandas I gave in Pandas there will be two different working data structures are there. One is series data structure, another one is data frame. I have explained few examples for series and data frame. So after that, if there is any missing value is there in your data frame or data set, how to replace that missing value with imputation concept, okay. Imputation concept is there in scikit-learn. We need to have some kind of fitting function or any kind of model to replace that NaN value or missing value with some kind of strategy. Mean and mode I have explained. There will be several strategies also. You just type the simple imputation function and you go through the scikit-learn library. There will be different examples are there. You try to practice those things. Then we came to probability and statistics, okay, and we have seen some basics of normal distribution and Gaussian distribution, and then binomial distribution, how we can implement this distributed function in Python. Then we came into one real-time example, that is a pizza delivery, okay. So they have given some problem statement in terms of PJOS and timeline, and they gave some standard deviation value, and within the timeline how to formulate your hypothesis. Okay, so based on that you need to reject your hypothesis, null hypothesis, or you want to accept it. Okay, there will be two different to solve this particular problem we are going for Z test. Okay, there are so many other tests also there. It depends on that problem statement. We need to select the respective probability distributed function and then respective model. Okay, to solve these problems. Okay, so with this I'm just concluding the session today. Next live session I'll give more examples on this probability and statistics. Okay, thank you. If you have any questions, you just ask me. Any questions? So if you don't have any questions, okay, good night all. I'll end the session. Okay, thank you all. Bye.